In this demonstration, we will exhibit the parallel auto-range and read of a new instrument. The FPGA module and the daughter board are mounted to the instrument, which is supplied from a benchtop power supply. The primary power supply is not used due to thermal issues. This design flaw has been corrected in subsequent versions, but we were unable to rework the FPGA design in time for this demonstration. A fixed resistor is connected to the breakout heads on the daughter board. In this demonstration, we will connect the resistors to channel 1. The FPGA is connected to a PC, and the bit stream is loaded. Upon loading the bit stream, the FPGA begins sending serial commands to the instrument. These configure the channels as transimpedance amplifiers, set the initial range, and declare biasing conditions. In this demonstration, we will bias the test resistor at 0.5 volts. With the instrument initialized, the ADCs start collecting data. If the measured output voltage of a transimpedance amplifier is below a threshold, the FPGA commands that channel to move on to the next range down. As the channel pictured here switches to its most sensitive range, the output of the transimpedance amplifier exhibits a transient. This occurs because the analog switches inject charge onto the negative input terminal of the amplifier as they change state. The RC behavior of the most sensitive range is much slower than the amplifier output, so it produces a dramatic spike. Once all channels have settled in a range, the FPGA stops sending serial commands to the range switches and begins collecting ADC readings for averaging. In this configuration, this goes on indefinitely, but the finished instrument will collect a specified number of samples. The recorded data is then sent back to the PC over the USB connection. The first byte in the format that is sent back is empty. The second declares the range in which the following data was captured. The last two bytes are a 16-bit ADC reading in 2's complement format. Here are some example readouts from this demonstration. The top 5 lines are averaging data from channel 1. The bottom 32 lines are readings from the end of auto-ranging phase for all channels. Please note that this config has a minor bug in which channel 17 always reports the same range data as channel 1. Channels 2 to 32 show a non-zero value because this value is the point at which the FPGA decides that the channel is close enough to being settled to declare that the auto-range is complete. Actual average data from an empty channel is much closer to 0. The lines between these two clusters of data are empty and irrelevant. In this demonstration, we test 6 resistor values: 2.2 kiloohms, 5.6 kiloohms, 8.2 kiloohms, 24.6 kiloohms, 1 megaohm, and 10 megaohm.